This conference will now be
Yeah,
recorded.
already we have done previously one demo, right?
Yeah.
Okay. Today, can I give you a recap of complete overview of the data science? Hello? Yeah,
Yeah.
general
Please go.
discussion. Yeah, we can start complete recap of demo.
Okay.
Then we will go to the Python. Is Python, what are the features? We'll discuss about that. I can show you some examples also. Okay. So before going to that, do you have any doubts in that earlier class?
No, I don't have any doubts.
Okay. Okay, we are gonna starting from base, starting onwards from scratch. So what is
Okay.
data science? Already we discussed. What is data science? Data science is a combination of mathematics, statistics, machine learning, and computer science. In simple terms, data science helps to analyze the data and extract the meaningful insights from it by combining statistics, mathematics, and programming skills and subject to expertise. This is a data science, right? So simply already I said to you, simple one single line definition, data turn into the data products. That is called data science, right? Next, what is the importance of data science? Do you have an idea? Nowadays, in our organization, what is the importance of data and data science? Actually, data science will help in extracting meaningful insight from that by combining various methods, technologies, and tools in the field of e-commerce, finance, medicine, human resources, and so on. Businesses come across huge amount of data. Okay, so data science tools and technologies help them to process all of them, and they have find out their data products. That is the importance of data science. So next, what are the prerequisites? So uh, when you want to being a data science, what are the prerequisites? Any idea?
No.
Already I said to you, data science having under the umbrella of data science. So we have statistics, machine learning, databases, modeling, then some programming skills. Okay, so domain expertise, statistic and mining, programming skills, analytical system, algorithms, and research. So these are the common areas of our data science. All comes under our umbrella of data science. So these are the prerequisites. In statistics, so you should have at least basic knowledge of stats. Are you aware of that? In 10th class or SSC or board level maths, board level stats.
Yeah.
The data science relies on statistics to capture and transform the data into enable evidence through the set of complex machine learning techniques. So mainly we are transform the data patterns to usable evidence through the use of complex machine learning techniques. So what are the basics are required? Already I said to you, mean, mode, variance, covariance, uh, test, t-test, g-test, hypothesis, test, null hypothesis, alternate null hypothesis. These are basics are required. Okay. Next, what are the programming skills are required? So either should master in either Python or SAS or Julia any other. But almost 90% of the companies are working in Python. So you should proficient or you should master in Python language, and you have an added advantage either on other language. So in our course time, I can completely explain data science with Python as well as, and also I can give the R. So that is the asset of our coaching. Okay. So next, and some SQL basic concept. Are you aware of that SQL basics? Hello.
Yeah, I'm listening.
Yeah. Are you aware of some basic SQL, some test MML or DDL, data definition language and manipulation language, DML, data manipulation language.
I
Simple.
heard about
If
it,
you
but
are
I don't know about it.
okay, if you want, I can explain you those concepts also. Just it will take 2 to 3 hours, not a problem. I can explain you. These are main requirement. Okay, in programming, Python, SQL, and a little bit knowledge about art, but I can give complete stuff so you can easily survive in the industry. Okay. So the most common programming language. So to successfully execute a data science project, it is important to install some level of programming knowledge. So you can proficient Python. So these are the added advantage R. Okay. Next,
Okay.
machine learning. So machine learning is one of the subset of our data science. It is also subset of our artificial intelligence. Without machine learning, artificial intelligence not working. Okay. Nowadays, already recently, or Bill Gates also explained the chat GPT. That is the artificial intelligence is a big competitor, or even though that is the Google or Amazon also. Okay, recently Bill Gates talks about that in one of the seminar, right? So if you want to develop those type of chat GPT or bot or being these are the, if you want to develop those artificial intelligence uh, tools, so you should learn the machine learning. So you can develop machine learning algorithms with the help of Python language or R language. Okay, so now we will discuss about here Python language. Okay, next, in machine learning, making accurate forecasts and estimates is made possible by the machine learning, which is a crucial component of data science. So you must have a firm understanding of machine learning if you want to succeed in the field of data science. Okay, next,
Okay.
uh, algorithms that comes under machine learning, programming skills, analytics systems. So we will do some data, different type of data analytics. Those are descriptive analytics, descript, next pre-requirement analysis. Okay, it's different type of analytics we can do here. Here, these type of analytics. What are those? Some descriptive, diagnostic, predictive. That is time series analysis or prescriptive analytics. So that comes under our data analytics. One of the role in our data science. Okay, data science, data engineer, all comes under our roles in our data scientist. Okay, and also you should know some database. So you are not working on some as a database administrator, but you can retrieve some data from databases, right? That's why you should know about some basic knowledge. So a clear understanding of the function of databases and skills to manage and extract the data must in this domain. Next, based upon our algorithms, that is machine algorithms. How can you pick that machine algorithms? Based upon our data type and domain knowledge, right? Data type and domain knowledge. This is domain knowledge. Okay. So what data you have? Different type of data we have. That is finite, quantitative, finite or quantitative. Another one infinite, continuous data or qualitative data. So we have two types of data and based upon our domain, whether you are working for retail domain, financial, healthcare, or insurance, whatever it is. So you should know about those domain knowledge and as well as based on the data, you can pick one of the algorithms. Then you can build a model. Meanwhile, you can do the data wrangling. The data wrangling is you can clean the data, scrubbing the data, and then you can move into your environment. So what are the perfect data here? Then we will start modeling. Okay? You may quickly calculate and predict using the mathematical models based on the data you already know. And models help in determining which algorithm is best suited to handle a certain issue and how to train these models. Okay. Next, here. So we have some of the examples already we discussed. So you can discover so many data insights, okay, based on the some of the retail companies, Netflix or Procter and Gamble, Amazon. So you can develop so many different type of data insights. Like our Netflix data mine movie viewing patterns to understand what drivers users interest. Okay, and
Okay.
uses that to make the decision in which Netflix original series to produce. Same way in Procter and Gamble, it utilizes time series analysis or forecasting analysis. So what are my profits in next week or next month or after 3 months or after 1 year, after 3 years? These type of future analytics is nothing but you can call it as a time series analysis or forecasting analysis. We can develop different type of insights based upon our client's requirement and based upon our data. Then finally, you can develop the data products. So based upon our data, you can develop different type of data products. We have so many data products are there in real time. Already we have Gmail spam filter, Spotify recommends music to you, Netflix recommends movies to you, Amazon recommends items suggest to you, okay, to buy determined by their algorithms. So I can explain in user cases how do you different type of algorithms converted to models. Okay, next, where does the data come from? Already I said, where does the data come from? Either in the flat files. What type of flat files you have? Two types, semi-structure and structure. What are the structure flat files? .xls, .csv, .text. These are the structured data formats. Okay, either you can connect to that data. That is, those are small data sets, or you can connect it to semi-structured data sets. What are these? .xml, .json, .bat, .dat, dat. Those are SAS files or .html files, and so on. These are all semi-structured data sets. And also you can connect it to some of the databases, that is SQL databases.
Okay.
What, what are SQL databases? Already we discussed earlier. Oracle. Oracle is one of the SQL database. So almost all RDBM systems based on the SQL, the structured query language. So you can store the data structurally in our RDBM system. Structure means our data goes into the rows and columns in the form of rows and columns in a table. Which every data stored in a row or column format in our table. So collection of tables which is comes under our database, and they have so many relationships, one-to-one relationship, one-to-many relationship, many-to-many relationship, many-to-one relationship. That's why you can call it as a relational database management system. You can connect the Redbrick, Teradata, okay, Oracle, the IBM DB to DBA. So many databases are there. Okay, Sybase. Next, you can also connect to some of the NoSQL databases. What are the NoSQL databases? NoSQL stands for not only SQL. Not only SQL means SQL allow only structured data, but not only SQL database allows any of the data, either structured data, semi-structured data, or unstructured data. So structured data means only the data which we can store in the form of columns and rows in a table. Okay, structurally or sequentially store the data. Okay, next, what is semi-structured data? Like our HTML files, XML files, or web crawling data. These are all semi-structured data. Next, what are the unstructured data? Like our images, graphs, audio files, video files, uh, and so on. These are unstructured data. So any type of data you can store in a NoSQL database. What are the databases we have? MongoDB, Neo4j, CoachDB, Apache HBase, Redis, Rake, Cassandra, Hadoop HDFS, Hadoop Distributed File System. These are all NoSQL databases. And also you can retrieve the data from the cloud databases. What are the cloud databases we have? Amazon Web Services and Windows Azure. You can also retrieve the data from those systems, those environments also. So finally, when you have the data, where you can store it? Hello, hello, Sakshi.
Hello. Hello?
Yeah. So, do you have any idea about big data Hadoop technologies?
No,
No, no idea, right? Okay.
no,
Actually, based on the big data technology, right? Based on the big data technologies, we are want to apply our analytics against the uh, analytics against the big data. So we are into the data science, data analytics, big data analytics, or data business analytics, statistical analytics, we are business statistical analytics, or machine learning analytics. So these are our data science, data scientists. So mainly the data big data Hadoop technology. Okay, so actually big data which is introduced in 2005 in 1.x version. Okay, so what is big data? A huge or large amount of data which you can store in our databases. How much large it is? Do you have any idea? That it large. How much is it? So are you aware of GBs? Gigabytes, GB, terabytes,
yeah, I,
petabytes. Are you aware of? Hello?
yeah, I'm aware
Yeah,
about it.
actually, we have bits, bytes. Bit is equal to 0 or 1, right? Bytes is equal to we have bits. Kilobyte is equal to 1024 bytes. Megabyte is equal to 8. 1 gigabyte is equal to 1024 megabytes. 1 4 kilobytes, 4 terabyte equal to 1024 terabytes. 1 exabyte is equal to 1024 petabytes. 1 zettabyte is equal to 1024 exabytes. 1 yettabyte is equal to 1020 terabytes. Almost 10 to the power of 24. Okay. Uh, uh, they can store into this big data. But big data access any type of data. Access either structure, semi-structured data. Not only structure, structure announced. So when you want to apply the analytics against the semi-structured unstructured data, now we are coming to the picture. Data analytics, the data science. That is in our today's business environment requires big data. Here, earlier we have only traditional environment. So traditional is only we have in this area. Okay, so we have some databases. We have some databases in this area. Next, historically, you can retrieve the data and move to the data warehouse, enterprise data warehouse. Then you can use any one of the BI tool like MicroStrategy, okay, or Tableau, or SAS BI, Business Intelligence, or OBIE, or SAS Business Intelligence, Object, Oracle Business Intelligence Enterprise Edition, or Web Focus. So many traditional tools are there. So those tools are their analytics only against the structured data. They won't apply their semi-structured. Not possible because these databases that are on the unstructured. These SQL database have only structured data. So at that moment, almost in the earlier 2007 or 10, almost all companies are they are doing only traditional analytics, not these type of unstructured analytics or semi-structured analytics. So when the data science came into the picture from the 2009 or 10 onwards, so we are applying as the big data. Okay, big data and every data, either it is structure, semi-structure, unstructured data. Okay, here now you can move complete these traditional data into the big data. Already so many 100 years of companies are available. Okay, they have so much data in their databases. Now you want to move the data into big data when you want to analyze it. Or if you want to do analytics against the structured data. Or if you want to directly connect to any data or any data. So our social media data, web crawling, or EMH data, social media data. Already these data you can directly store in the big data either in the GES or NoSQL databases, okay, or Spark. So based on that, you can retrieve the data and apply your data analytics against that data with the help of our Python language, or you can use many of the type of models. Okay. So now big data contains each and every data. That's why today's environment, almost all companies are put their data into their either cloud databases. Cloud database also store their data in their data centers. Those also accept any type of data. Okay, the structure, semi-structure, unstructured data. So now you can retrieve the data from any of these environments, either plot files, data, or the relation database management systems, or social data, or big data, or NoSQL databases, or Spark, or big highly access, high only structured data, or HDFS. So now you can retrieve the data and apply our analytics against the data. So this is the today's business environment. Next, what type of analytics we can do here? Data analysis, one of the part in our data scientist, data science. So what type of analytics we are doing here? So
Yeah.
here we have descriptive analytics, diagnostic analytics, predictive analytics, prescriptive analytics. Descriptive analytics means just to have information what happened based on historical data, what happened. That is descriptive analytics. So it helps accurately displaying the data points, patterns that may appear that satisfy all of the data requirements. In other words, organizing, ordering, and managing produce information that is insightful, updating the data to the specific supply data, the raw data, a form that will make it simple to grasp and interpret. So, of analysis we are here based on the historical data. Now, I want to ask what are my revenues and profits in particular year, particular area, region, particular product. That is diagnostic analytics. What is diagnostic analytics? That is, we can do from higher level to lower level. Suppose now you are now you are applying analysis in the descriptive analytics countrywide. Now you want to apply your analysis against the branch wise. So country contains states. When you click on that, it displays that is uh, higher level to the lower level. Okay. Now when you click on the state, it displays the particular regions. When you click on that, that region contains some cities. When you click on the city, that display the branches. Suppose if you take Mumbai, how many branches are there in our ICICI Bank or HDFC Bank or Indian Bank? Suppose you want to apply our analysis. So branches are displayed. Now I want to retrieve, I want to apply my analysis in a particular OI branch in ICICI Bank. At that time, so we are coming from higher level to the lower level. Drill down this from higher level to this. This is drill down. Okay, drill down the analysis, and particularly you will find out particular profits or sales in a particular OI branch in uh, in a particular city, Mumbai, in a state Maharashtra, in India. Okay. Now you are going to country to state, state to city, city to branch. This is drill down the analysis. That is diagnostic analysis. And also when you apply a particular analysis in a particular product, so in our branch, there are so many services or so many products are there. So what type of products have sold out more? Okay, highest sales. Now you want to bring that analysis. That is diagnostic analysis. Okay, so in this way, there is drill down or drill up. Drill up is lower level to higher level analysis. Suppose now you are in the date wise. Now currently you are finding out the analysis a particular Christmas Eve day or particular holy day. What are my analysis? What are the products I have sold more? So now I want to find out particular week or particular now day to week to month to quarter to year. This is a lower level to the high level analysis, that is drill up analysis. This type of analysis we can do with the diagnostic analytics. So it is in a in-depth examination to understand why something happened, why did it happen. Okay, techniques like drill down, drill up. These techniques we can apply here. The data discovery, data mining, and correlations are used to describe it. Okay, so multiple data operations and transformations may be performed on a given data set. Discover unique patterns in each of these techniques. This is diagnostic analytics. Next, we'll go to the predictive analytics. And also you can call it as time series analysis or forecast analysis. So what is predictive analytics? It is the process of using historical data along with various techniques like data mining, statistical modeling, machine learning to forecast the future results. Already I said you. Now, in our company, currently, last month got 1 crore profit. Now you want to analyze how will I get the profit in next month? How much profit will I get in next 2 months, after next 3 months, or after 2 quarters, or after 1 year, after 3 years? These type of analysis are called forecasting analysis or time series analysis. You can predict the analytics, you can predict particular way. That is predicting analytics here. So we can utilize the trends in this data. Business uses the predict analysis to spot dangers or opportunities. So in our normal traditional analytical tools also doing all these three types: descriptive, diagnostic, and predictive. Okay. So now in our data science, you can do all these analytics as well as finally you can do prescriptive analytics. What is prescriptive analytics? Suppose I can use simple example. Suppose one of the guy got a fever. Okay, what he can do? They want to cure that fever, right? That's why he wanted to go to the doctor. When he went to the doctor gives complete prescription. Okay, take tablets, fever tablets, daily price. If he has any uh, cold or cough, take syrup daily twice, or take antibiotic daily once. This type of prescription he will give, right? So if the particular patient follows that prescription, that fever will be cured. If not follow that prescription, fever not be cured, right? So that is based on the prescriptive analysis. That is prescriptive. Based on the prescriptive, if you follow that, you will get good result. If you are not follow that, you are not getting good result, right? Same way, based on the prescriptive analytics, our stakeholders take the decisions. Okay, that is the final analysis. Here only you can do machine learning analytics. Based on the machine learning, you can develop so many products. Then we will move to the reality. So prescriptive analysis advances the use of predictive data. So it forces is which is most likely to occur and offers the best course of an action for dealing with the result. It can assess the probable effects of various decisions and suggest the optimal course of an action. So it makes the use of machine learning recommendation engines, complicated event processing, neural networks, simulation, RAF analysis, and so on. So mainly we can do these type of analysis in our prescriptive analysis. It is not possible in our traditional analytics. So that is the importance of prescriptive analysis. That's why mainly we are moving to the data science. Okay. Next. So what is the data science project life cycle? Do you have an idea? Project life cycle.
No.
First, we can retrieve the raw data. Anyway, either small databases or big databases or NoSQL database or cloud database. Okay. So what are the clients give the permissions? Now you can go to that based on that requirement. You can retrieve some of the data from those source systems. Then you can process into your system. Either you can use Python language or R language, whatever it is. Okay. Now that data is available based on the requirement, you can want to apply different type of insights. Like that means you can generate different type of graphs, either pie charts, donut charts, or vertical bars, or horizontal bars, or line graphs, whatever you want. So you can do some of the analytics or some of the insights to develop based on the data. Okay. So before going to that, You can clean the data. That is data wrangling. So what type of data you are cleaning? Either if you have any unnecessary data or any misuse data or erroneous data, first you can remove it. When you have the perfect data, at that time you can start your analysis. Same way, when you want to develop a product, so you can retrieve one of the algorithm from your machine learning. How can you pick up this? Based on your type of data and domain. So you can pick up one of the algorithm. Suppose you are into the social media. You want to apply one of the to develop one of the product. At that time you can retrieve naive Bayes theorem. Okay, that is one of the classification algorithm. Suppose if you want to apply, you have a continuous numerical data. Okay, at that time you can go to the unsupervised learning association rules in the retail domain. In this way, based on the data and domain, you can pick one of the algorithm and then you can apply different, you can generate different type of models. So based on the visualizations and models, the clients take the decisions. Then they move the products into the reality after completion of testing. This is the data science project lifecycle or workflow. Okay. Next, what are the benefits of data science? What is the benefits of data science? Actually, improve the business predictions, interpretation of complex data, better decision making, product innovation, improve the data security, and developing of user-centric products. Okay. So, and what are the responsibilities to handle as a professional data scientist? What are the responsibilities we have in our real time as a data scientist? First, gathering, cleaning, organizing the data to be used in a predictive and prescriptive models. Next, analyzing vast amount of information, discover the trends and patterns. Using the programming languages, either you can use Python, R, SAS, Julia, whatever you want. So now in our course, I can explain you both the language Python and R. So you should proficient or you should master Python language. Okay. So using programming language to structure the data, convert it into usable information. Next, working with the stakeholders like our directors, finance directors, or our managers, or entrepreneurs, or clients, whatever it is. Okay? Working with the stakeholder to understand the business problems and develop the data-driven solutions. So, developing predictive models using statistical models to forecast the future trends. Next, we can build, maintaining, and monitoring the machine learning models. Then developing an advanced machine learning algorithms and other analytical methods to create the data-driven solutions. Then communicating the data-driven solutions to the stakeholders. Then discover hidden patterns and trends to massive data sets using a variety of data mining tools. Then you can develop so many validating data solutions to the data visualizations with the help of Tableau or Power BI or any other client specifications. You can develop different type of visualizations, report, dashboards, and stories. There is the response. These type of responses are required for as a data scientist. Okay, next we'll go to the here. What are the comparisons or differences between R and Python? Here, as a model building, both are similar, both are better. Next, model interpretability, R is better. In the production, Python is better. Community support, are having good community support over Python. Data science libraries, both having similar libraries. Almost thousands of libraries are available in Python as well as R also. The data visualizations compared to Python are having more data visualization libraries are there, tools. In learning curve, Python is very easy compared to any of the other language, not only R. Okay, here. Next, machine learning. So, what is machine learning? Machine learning. Machine learning enables Machine to automatically learn from the data, improve the performance from experiences, and predict the things without being explicitly programmed. That is called machine learning. What is the goal of machine learning? Which is to get the software to make the decisions, learn from the data without being programmed explicitly to do so. What types of machine learning we have? We have different types of machine learnings are there: supervised learning, unsupervised learning, and reinforcement learning. Almost reinforcement learning and unsupervised both are quite similar. Mainly in our real time, we are in supervised learning and unsupervised learning. Okay. Next, how does machine learning work? Machine learning system learns from the historical data, builds the prediction models. Whenever it receives new data, predicts the output for it. Okay. What are the features of machine learning? So machine learning uses the data to detect the various patterns in a given data set. It can learn from the past data and improve automatically, then generate different type of models. Okay. It is a data driven technology, and machine learning is much similar to the data mining, as it is also deal with the huge amount of the data. Okay. What is the importance of machine learning? Why we go for machine? What is the importance? Actually, machine learning can be easily understood by its use cases. Currently, machine learning is used in self-driving cars, that is, robotic cars, cyber fraud detection, face recognition, speech recognition, our friends suggestion by the Facebook, and so on. Various top companies such as Netflix and Amazon have built machine learning models that are using a vast amount of data to analyze the user interest and recommend the product accordingly. Here. So we have so many key points which you shows the importance of machine learning. What are those? Actually, uh, a rapid increment in the production of data, solving complex problems that are difficult for a human, decision making in various sectors, including finance, finding hidden patterns and extracting useful information from the data. Next, what is supervised learning? What is supervised learning? Actually, you have three types of learning, right? Supervised, unsupervised, and reinforcement. What is the supervised learning? Supervised learning is a type of machine learning method which we provide a simple label data to the machine learning system in order to train it, and on that basis it predicts the output. So in supervised learning, we know the output based upon our data, okay, but not in our unsupervised learning. So what is the goal of supervised learning? Which is to map input data with the output data. The supervised learning is based on the supervision and is the same as when a student learns things in the supervision of the teacher. Okay? The example of the supervised learning is a spam filtering. Already Google spam we have. So when any person send a mail to your mail ID, now that Gmail understand either it is a spam or original mail. If it is original, it is perfect mail. That move into the inbox. If it is any ad, any other thing, or any other irrelated information, that is moving to the spam. So based on our algorithm, our machine learning algorithm, it is separated that. Okay, that is the importance of our machine supervised machine learning. This is one of the example of supervised learning is spam filtering. Okay, and these supervised learning here are classified into two types. Those are classification, regression. Okay, what is when we go for classification? When you have the categorical data and historical data, you can go for classification. And when you go for regression, when you have the continuous data and as well as numerical data, that you can go for regression. So I can give complete details about the time of discussing machine learning. So now I'm giving the outline of complete machine learning. Okay. Next, what is unsupervised learning? Here, unsupervised learning is a method in which a machine learns without any supervision. Is we are not providing any label data. So the training is provided to the machine a set of data that has not been labeled or classified or categorized. And the algorithm needs to act on the data without any supervision. Okay. So the goal of an unsupervised learning is to restructure the input data into new features of a group of objects with similar patterns. What is the example? For clustering. Already where you can use the clustering? We have already said it earlier media domain. So we will get each and every second. We will get the data from the news reporters all over the world in different languages. You can store each and every data in our data centers only when you want to release the bulletins in different languages. At that time, you can move the data. What are the similarities we have? Similar character or similar feature we have. You can put into a cluster. Suppose Hindi data you can put into Hindi cluster. Marathi data you can put into a Marathi cluster. Or Tamil data you can put into a Tamil cluster. Telugu data you can put into a Telugu cluster like this. Now the Telugu readers when the news readers want to uh, discuss their bulletins. At that time, they grab that data from the Telugu data. Hindi people, Hindi readers, they want to get rid of the Hindi cluster. So this type of clustering we can do in our unsupervised learning. So in unsupervised learning, we don't have a predetermined result. The machine tries to find useful insights from the huge amount of data. So it can further classify into clustering and association. Clustering we can use in the media domain. Association we can use in the retail domain. Okay. Next, third one is reinforcement learning, which is quite similar to the unsupervised learning. So learning is a feedback based on the learning method, in which a learning agent gets a reward, either good or bad, or either you can get the that is award, or you can get a some what is it fine award or fine. These type of things we can do here. So mainly gets a reward for each right action, gets a penalty for each wrong action. Okay. The agent learns automatically these feedbacks and improves its performance in reinforcement learning. So the agent interacts with the environment and explores it. So mainly our chart GPT based on these type of reinforcement learning. Based on the given feedback, they will retrieve the based on our prompt, they retrieve the data from that reinforcement learning, what that contains, they retrieve it and display the data based upon our requirement. Okay. Some examples are robotic dog, chat GPT, Bard, and so on. So which automatically learns the movement of learns it based upon our prompts. Okay. Next, what are the applications we can develop with the machine learning? Before going to that, we have divided into mainly in real-time two types, supervised and unsupervised, and also supervised classified into classification and regression. Classification and regression both are quite similar, but when you go for classification, when you are based on our data, you have the finite, categorical or quantitative data, you can move to the classification. Either you can use KNN algorithm, decision tree classification, or logistic regression, naive Bayes. Okay, naive Bayes, which is one of the theorem in our probability. So when you want to work for our social media algorithm, at that time you can retrieve this naive Bayes theorem. Okay, next, when you go for regression, when you have the continuous and numerical data, you can go to the regression. So you can apply the linear regressions, polynomial regressions, decision trees, there is decision regression trees, random forest regression. Okay. Next, when you go for unsupervised, so when you have a huge amount of data that is continuous and which is similar characteristics. So at that time you can go for clustering, K-means clustering, or principal component analysis, or support vector dimensions. So when you have a huge amount of data mining data and you have numerical data, okay, and continuous and categorical. So at that time you can go to the retail domain. You can use the association analysis. Okay, see here. So what type of application have you applied based on machine learning? You can apply image recognition. So image recognition is one of the most common applications of machine learning. It is used to identify the objects, persons, places, digital images, and so on. The popular use case of image recognition and face detection is automatic friend tagging suggestions. So already maybe you can see in your Facebook or anything. Okay, image recognition, automatic friend tagging suggestion. So Facebook provides us a feature of auto friend tagging suggestion. So whenever we upload a photo with our Facebook friends, then we automatically get a tagging suggestions with the name. The technology behind this is a machine learning face detection and recognition algorithm. Okay, it is based on the Facebook project name Deep Face, which is responsible for face recognition and person identification of the picture. So one of the algorithm, machine learning algorithm. Next, speech recognition. While using Google, you get an option of search by voice. Suppose go to the Google. So when you open the Google, automatically it displays. Either you can search by typing any of the words, or you can click on this search by voice. So when you call what is machine learning, automatically it voice is converted to the text message and it searches and displays the answer here. What is machine learning? It displays it. So it is also one of the machine learning algorithm. So Google here display complete machine learning links or blogs, whatever it is. So you can search here. Okay, this is one of the applications. See here. So next, we have so many applications are there. Traffic prediction. Suppose you want to visit a new place. Uh, when you want to visit a new place, you can take help of Google Maps. Okay, which shows the correct path and the shortest route to predict the traffic conditions. Okay, next, product recommendation. Already I said to you, Netflix recommends you the what type of movies you want. So Netflix recommends movies to you. Is Spotify recommends music to you. Amazon suggests uh, some of the products. What type of products you want to buy? Their related products are suggested to you. Okay, there is product recommendation. So machine learning is widely used by various e-commerce and entertaining companies such as Amazon, Spotify, Netflix for product recommendation to the user. So whenever we search for some products on Amazon, then we start getting an advertisement for the same product while internet surfing on the same browser, and this because of the machine learning. So Google understands the user interest using the various machine learning algorithms and suggests the product as per the customer interest. As similar, when we use Netflix or Spotify, we find some recommendations for entertainment, series, movies, or whatever it is. This is also done with the help of machine learning. Next, automatic tasks. That is also one of the application with our machine learning. One of the most exciting applications of machine learning is self-driving cars. Which is a significant self-driving cars like Tesla, the most popular and manufacturing company is working on the self-driving car. Cities use unsupervised learning methods to detect object while driving. Already I said email spam. Okay, next visual personal assistant. So we have various virtual personal assistants such as Google Assistant, Alexa, Cortana, Siri. So many personal assistants are there, right? So as the name suggests, the help is finding information using our voice instruction. These assistants can help based upon our instruction. Okay, so we have so many applications are there: online fraud detection, stock marketing, medical diagnosis, automatic language translation, and so on. So this is the main overview of our data science here. So many use cases are there. Yes. So when you go for model in media use case, based upon our in our media use case, you can use the clustering analysis. In our chemist clustering, market basket analysis, you can use the association rules. In our healthcare, you can use parallel processing. In social media, name-based classifier. Okay. So this is the way you can use the data science projects and machine learning applications. Okay. Do you have any questions? Hello, Sakshi. So now I have given the complete picture about the data science. Do you have any questions? You can ask me. Hello? 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 Sakshi, are you there? Hello? Hello?